Today we are fault finding why this socket isn't working, but equally we can tell there is some damp present in the property. My client just bought this house. He needs some extra sockets installed in this kitchen just to help with all the appliances that will be here, but at the moment we know this isn't working. We need to find out what's happened, so let's get going. Let's just get some understanding. Kind of, it appears that it is. That's interesting, that should never happen. So right hand side of the socket isn't working and that one is. That one is just down to a broken faulty socket. Yeah, even a switch does nothing. So very rarely actually this should be a case where the socket, just like this one, isn't working. Not sure if you can see this green stuff right around the screw. So you can see here. I think this will be a problem with oxidization of the cables along with damp in the walls. You might be able to tell that there's something going on with these screws, quite rusted. Okay, so there's lots of silicone around this socket. So these are the original cables coming down from the fuse board from a circuit. This is a spur, and that's the new socket, that one that's been added, installed at some point. And they just spurred it off. That's not a problem, that's still doable. Rather than spurring off, perhaps they could extend the ring. And look at this cable, that cable actually isn't long. All that oxidization on this copper cable. Yeah, pretty bad. What we're gonna do is, we now need to go and find what circuit is this. So here's what we've got, quite old fuse board. Lights 32, 32, 32, so it's one of those. So sockets, first floor, ground floor, and ring circuits, whatever that is. Nope. Yes, there is a main RCD protecting everything. There's quite old fuse board. We've got big 60mm cable coming down, and then we've got little 6mm. Part of the original earthing, I believe so. Let's verify this, if the power is off. Live to earth to neutral, neutral to earth, nothing. That's good. We can now proceed and remove actually, because what client wants is, he wants to have two sockets. We are too close to an oven anyway. We will be like attempting to move the whole thing and install additional socket right here. Yeah, look at this cables. Oh my god. I've had a few videos about these. It's just damp. All the plasticizer that's used for making this insulation on those cables is just reacting with damp, with working temperature, and it's doing that. That's really bad. It's non-conductive. This goo, green stuff, basically makes the socket not working. So this actually went inside the termination screw and affected the socket inside. Yeah, pretty bad. I've already managed to open these two sockets, and although these cables are nice and long, these ones are super short. We're going to replace the full back box. That one's all corroded. The lugs on each side do not hold the screw very well. Well, actually, they do, to the point that you can't really unscrew, and that's what I'm doing here. Absolutely nightmare. So what we want to do now is prepare the worktop with padding. Now we can start putting this all in. I'll rip this socket off anyway, because this is what I want to put in. It's time for SDS. We need to chisel this out, cut that one out, because what I do sometimes is I just use a blunt multi-tool blade. The plaster is quite soft. So we got all the metal boxes in. Surprisingly, that wasn't too bad, because the capping is everywhere. I was able to pull an extra length on one of the cables. Using these connecting nipples, I am transferring one cable to the other socket, just like so. That's what I did there. Here, down the bottom, I'll just put a new cable connecting these two. Just like this. And there. I've got some filler on the van. Am I gonna just touch up with the filler so client can use it straight away? Because it was quite easy to get this all done. So, some PVA, let it dry, and then we can tidy up while this is drying. So we have to do a little bit of the cleaning. So just as you can see, we've just cleaned with this brush all the ends of the cable to expose the copper, just so we can get a cleaner, better connection on all of these. That's more of a shiny copper now, rather than this corroded kind of cable that was covered with this green blue stuff. So let's put the sockets on now. Okay, so we finished. The sockets are in. We did fill the gaps because they were just so big. We wouldn't be able to even put the sockets on in any way. So this is not finished, and usually we don't do that. But in this case, I just had to do it. Otherwise, we wouldn't be able to even fix the sockets and check them. So in this property, we've got a challenge because the green stuff that's oxidizing the cables is really not helping. So the problem we have here is the oxidizing of the cables is really not helping the installation and actually degrading the whole installation. I tested the continuity of the circuit from the fuse board to the sockets. We've got a continuity, but we got really high resistance on that continuity. That means that this green stuff really is deteriorating the whole installation. I'm about to tell the client that he will need to essentially at some point get ready to have it rewired. In the meantime, what we could do to extend that period perhaps is to replace all of the sockets in the house, all of them, and clean the cables like I did here with those in the kitchen. So either scrubbing it, and there is that special liquid that you can just put it onto the end of the cables, just preventing with that oxidization. I believe so. So this would be the course of action. And for this one, client, is always better to use the sockets as extension leads. Extension leads are not, especially in the kitchen, not safe. And also, we moved the sockets away from the cooker as they were not complying with building regs and electrical safety. That's done. I'm going to speak to a client after the next one. Thank you.